So the next step is to get the cone working as well. So we've got the line of sight quite successfully, even if I do say so myself. That's arguably the trickier of the two. So let's dive back into the code. And we're going to work on this check target in cone function. And then we're going to adapt the update function to make use of it as well. But we'll start by getting the actual main bulk of it done. Structure is fairly similar to the line of sight in that we do want to return false if we ever get to the end. If we get to the end of the function, it means that we don't have the target in the cone of sight. And we also want to start the same as well. We need to first figure out the target vector. So that's our vector from the enemy to the enemy's target. So I'm going to copy that line and I'm going to paste it in. That's probably where the similarities end, really. The next step is strictly to do with the cone. So let's just refer to my notes as well. We want to figure out the angle from the enemy's facing direction and then its desired facing direction. So the desired facing direction is that target vector. That's where we want to be looking in order to look directly at the player. So we're going to store this angle in a float. We'll do float angle equals. And we're quite lucky in this particular case because Unity has a function built in. Not always the case in all game engines. If you're doing this in something like Flash or I don't know, Game Maker, I'm not all too familiar with, it's quite possible that they don't have a built-in function to tell you the angle between two vectors. So it's worth swatting up on something called a dot product. Dot product will give you the cosine of the angle between two vectors, and you can then reverse engineer it to figure out the actual angle, a bit like how we did with the tangent in the last couple of videos. So that's worth swatting up on just in case you ever find yourself in that situation. It's just good to understand the workings behind things anyway. But I'm waffling, so let's get on to it. So we're on vector 2, we're sticking in vector 2 form because why not? And we want to do the dot angle function, and that will, as you can see there from the little suggested text, it will give us the angle in degrees between from and to. So our from vector is the vector that the object is looking down. And obviously by now you know that objects in a 2D game in Unity look to the right. So our facing direction is transform.right, and then the direction that we would wish to be facing is the target vector. Target vector. Okay, and that will now store the angle in degrees between the direction we are facing and the direction we need to face to see the player, or to look directly at the player. And we can then question that. So we can say if, in brackets, angle, and then this is the conundrum. So the temptation might just be to say, if the angle is less than the cone angle, perfect. But what you've got to think, if you're looking forward, imagine you're the enemy in this game, you're looking straight forward, and you've got this cone of vision that's, say, 60 degrees. If you're looking straight forward, to go to the edge of your cone of vision is actually only 30 degrees either way. So we need to half the cone angle to really check if the player is inside of it. So if the angle is less than our cone angle divided by 2, that means the player would reside inside the enemy's cone of sight. Because looking straight forward, you only have half of the angle to move left and right to actually reach the end of your cone. Hopefully that makes a little bit of sense. Makes sense in my head at least. Try drawing it out. If you drew a cone of sight out from an enemy and drew a line straight down the middle of where it's really looking, you've halved the angle, haven't you, to the left and the right edge. And if we do that, if the answer is still yes, we can return true, because it means that the player is within the angle bounds that we've set. So check target in cone figures the vector from the enemy to the player. It then figures out the angle, and it asks if that angle is less than half of our full field of view. If it is, it returns true. If it's not, it returns false. And now we can jump to the update function. We can make another boolean underneath, and we can call this in cone, and that can use our check target in cone function. And we're nearly done. So we've got two booleans that both true or false for if we are in sight and if we're in the cone. We just need to amend this if now. So if we're in sight and we're in cone, then we do the chasing behavior. so close to being finished. So let's save that, go back to Unity, hit play, and let's just get to a position where we should be seen, and you can see there that the enemy's giving chase, and then when it turns away it's behaving normally. So even though we're still in line of sight, we weren't in its cone. When we're behind it, it can't see us. Even sometimes when we're just above it, it can't see us. And there is also another issue in that whenever it fires a bullet, it can't see us, and that's because, temporarily at least, the enemy's raycast sees its own bullet instead of seeing us. So that is a slight issue. It's something that we can work around by manipulating the layers that raycast actually has effect of. We can just tell it not to be able to see any enemy at all. So any ray beamed out from that enemy just goes straight through it, straight through other enemies, other bullets, until it hits a player or a wall. I might do an extra little bonus video on that, we'll see. But yeah, it's working. The next step is, in the next video, to make it change its behaviour. So when it sees us, instead of just continuing to spam bullets and move, it's going to do one or the other. If it can't see us, it'll move. If it can see us, it'll spin towards us and shoot at us.